Archimedes had shown something extraordinary. Infinity could be used. Curves could be measured. Areas could be calculated. The impossible could be trapped between better and better approximations. But Archimedes was not the end of the story. The search continued across civilizations. Did mathematics simply wait for Newton? No. That is the mistake many stories make. The road to calculus passed through many minds, many languages, and many different ways of approaching the infinite. Greece was only one beginning. In China, Liu Hui returned to the circle. He did not need modern calculus notation to understand a powerful idea. He refined polygons again and again. More sides, smaller gaps, better approximation. Precision grew by shrinking error. Begin with 6 sides, then 12, 24, 48, 96, then hundreds, then thousands. The polygon seems to disappear into the circle, but the lesson is not that the polygon becomes the circle. The lesson is more subtle. The error moves towards zero, but approach is not the same as equality. Centuries later, across the Islamic world, mathematics flourished. Astronomy, geometry, and optics demanded precision. Scholars studied light, reflection, curves, areas, and volumes with extraordinary seriousness. Ibn al-Haytham studied light, vision, and curved geometry. The infinite was not only a philosophical idea, it was becoming part of calculation, measurement, and proof. One powerful idea was the use of sums. A complex shape could be broken into measurable parts. Small pieces could build a larger object. A volume could be understood through accumulation. This is not yet modern integration, but the direction is unmistakable. Mathematics was learning to add the small in order to understand the whole. Then, in southern India, another remarkable step appeared. Madhava and the Kerala school developed infinite series. This was a different kind of infinity, not polygons closing around a curve, not only areas being exhausted. Numbers could be reached through endless expressions. Consider pi, a number hidden inside every circle. An infinite series begins, 4 minus 4 thirds, plus 4 fifths, minus 4 sevenths, and onward. The terms continue without end, but the values move closer and closer. 3, 3.1, 3.14, 3.141, 3.1415. Closer, slower, but still approaching. This is a new feeling. Infinity can calculate. The history of calculus is not a straight line. It is a network of questions. How can a curve be measured? How can an error shrink? How can small pieces accumulate? How can the infinite produce a finite answer? Different civilizations touch different parts of the same deep mystery. But something was still missing. Mathematicians had learned to approximate. They had learned to accumulate. They had learned to use endless processes. Yet the 17th century was about to make the problem sharper. Curves, volumes, and tangents were becoming harder to ignore. Next, before calculus, the age of curves, volumes, and tangents.